involved in.
You might want to turn off the lights because of the glare.
All right, let's do that. Then. That's
Now
better.
make sure you have Chromebooks out.
Could you flip that light on the back on top of the left table over there so I think you have something to see there? All set? We recording? Okay. Today we're going to take a look at Chapter 2 of the course. This is one of my most enjoyable favorite topics. It's about the Copernican revolution. It's probably the single most important event that happened in science, period. If you were to take any single other event, atomic bomb, solar power, inoculations, steam power, all of those different things, they all get trumped by the Copernican revolution. And the reason why is this was the first time we took mysticism out of nature and started to learn that there's an order to the universe. This is the first example of it. And it was men like Nicholas Copernicus, Johannes Kepler, Galileo Galilei, and Isaac Newton. They're the four biggies that really push us from having astronomy no longer what we call physical astrology, but actually calling it pure scientific astronomy. For millennia, we looked at the skies, and for millennia, we saw things and we drew conclusions that weren't necessarily there. If you were born under this zodiac sign, you had this personality. This was going to happen to you, this was going to happen, this was going to happen to you. The universe, the Earth was the center of the universe and everything revolved around it. All these ideas that came about were initially challenged at this very, very crucial point in time. And because of that challenge, it forced mankind to think of the skies and the stars as something other than a place that God's put together for us. That there was a physical order of the universe that's explainable and that's testable. So we'll take a walk through the Copernican revolution, which really launched us from previous mysticism into what we call true science. So we're going to look at ancient astronomy. Also, at this time, astronomy and the words astrology were used hand in hand. Many people that we acknowledge were great astronomers were also astrologers. And there was a whole lot of not just mysticism attached to it, there's a lot of politics attached to it also. If you were a court astronomer, you were the only one who could make predictions. Because the easiest way to get a kingdom to crumble was to predict its downfall. Or to tell, this is the time to go to war, when you knew it wasn't a good time to go to war. Or, make this move, plant this crop, put this person in power, take this person out of power. The court astrologers had quite a bit of power, and if they were considered wrong, they were executed. So it was not something that was taken lightly. A whole lot of politics and a whole lot of governing took place. When you look at history class, and you find that a certain battle occurred in Roman times, or pre-Roman times, or during Alexander's times, or the Ottoman Empire, a whole lot of reasons why wars were fought at the time they were fought was because of the stars. The planet Mars would kick up a dust storm, and thousands of people on the planet Earth would die because they would look up at the sky and they would see Mars, the god of war, was bright and red and angry, and he had to be satisfied. How do we satisfy Mars, the god of war? We go to war ourselves, and we kill our enemies, and our enemies kill us, all because of a dust storm. So we started to take a lot of the mysticism out at that point. We'll start looking at things like ancient astronomy, the geocentric universe, the universe where the Earth is the center of the universe. We'll look at heliocentric models of the solar system, where the sun is the center of the solar system, and how we prove that the sun is the center of the solar system. Excuse me. And that launches us into the birth of modern astronomy. That's why this is considered such an important topic. That's why it's one of my favorite topics to talk about. We'll look at the laws of planetary motion, the dimensions of the solar system, how big everything is. We'll look a little bit about Newton's laws of motion and what's called Newtonian mechanics. So, every single continent on the Earth, every single one of them, except for the Antarctic, has evidence of a solar observatory on it. And they all have names you've heard of in the past. The big ones everybody heard about is Stonehenge. Everybody's heard about Stonehenge. But you could add to it places like Chichen Itza and Abu Simbel, Angkor Wat. These are all places that were basically, they were places of religion and places of worship, but they were worshiping the sun, the moon, and the stars. So basically they were primitive observatories. Even in the United States, the Buffalo Medicine Wheel, found in the northern plains. The Anastasi Sun Temple, found in the American Southwest. The Mayan temples, all of them are built and aligned with the stars, or they align with the rising and the setting of the sun during the summer or winter solstice, depending upon the situation. So we have evidence that this has been going on. The study of the skies has been going on since before ancient times. Here's the spokes of the Bighorn Medicine Wheel in the American, I think it's the American Mid-Northwest. And all the lines on here are aligned with a certain day of the month that the sun is going to rise or the moon is going to rise up in the sky. And some of the markers show a specific star pattern or constellation was going to rise in the sky at that particular moment in the year. Now, while the sky is very, very complex, we have what are called constellations or mapped regions. We have 88 of those mapped regions between the northern hemisphere and the southern hemisphere. 88 is a lot, but it never changes. So if you're a person who studies the stars for 5, 10, 15, 20, 40, 50 years, the sky pattern becomes very, very set and concrete. And you know at this time, at this date, that this star or this thing is going to be happening in the sky, and it gives the first sign that the universe has an orderly network to it. This is the Temple of Caracol in Mexico. Instead of having large stellar cylinders or large monoliths to mark them off, they're one of the first that actually did windows, where the sun would come in and it would rise at a certain time of the day. The sun would go right through and it would strike a marker on the back wall through that window. They called them niches, is the proper term for them also. You'll notice that the people in this picture are of definitely Middle Eastern or Arabic descent. Many of the terms, many of the names, much of the terminology of astronomy is Arabic in nature. The names of the big stars out there all derive from Arabic names. And the reason for this is twofold. One, the rise and fall of Christian-based civilizations, when they went from one power to another, resulted in the destruction of records. The Roman empires, much of their records were destroyed when the Germanic barbarian nations went in and took out Rome. The only thing that saved them was outposts in places like Ireland and Scotland that had complete records that weren't touched by the Germanic tribes, actually were preserved. That's how we know as much as we know about Roman law. The burning of the library at Alexandria, Egypt, destroyed much of what's considered Greek and Roman and Western European knowledge of the skies. They studied just as much as the Arabic nations did, but the Arabic nations, because of a lack of turnover in major powers and a lack of destruction of their records, has led us to use Arabic-based information. Not to mention that a lot of Arabic nations were nomadic. They moved from one part of the world to the other, and their main source of navigation, especially if they were crossing hot deserts or hot areas, was they moved at night. So if they moved at night, the stars became their navigation, it became their road map. So they got very, very good at mapping and charting and observing those, and that's where we get a lot of our information and a lot of our notes from. So they noticed, they observed the sun, the moon, stars, and 5 wandering bodies. Mercury, we call it, Venus, Mars, Jupiter, Saturn. Those 5 are named after Roman gods because we had a lot of statues and a lot of worship by Romans of these 5 gods. And because of that, they were able to get preserved as the names that are named for planets. Moons going around the solar system are actually almost all named after Shakespearean characters now. If you look at the major ones that are found around Jupiter and around Saturn, many of those are named after characters from Shakespearean plays. Dwarf planets are now named after Polynesian or Inuit gods. That's the latest trend they're using. So each different group has a different series of names to them, dedicated to a different group in these cases. Kind of acknowledge the fact that astronomy really truly is a worldly topic in this case. So, what is the geocentric universe? The geocentric universe is kind of a bit of common sense. Aristotle and those of the times of antiquity were very, very big on common sense science. I get up in the morning, it's the middle of, in the Mediterranean areas, there's not a lot of clouds in the area, especially in the mornings and the afternoons. So I'm able to make a lot of observations in the sky, nighttime and in the mornings. I notice that as I get up, the sun rises in the sky, it crosses the sky, and it sets. The next day, it rises up again. So what happens? People make stories about how the sun has to travel through the underworld and the evils of the underworld, and as it navigates through the underworld, it then rises the next morning, continues up here. So we have this idea that the sun goes around the earth. Kind of natural. So you see across the sky, okay, so this object goes around us, because we don't feel our own movement. The moon. Sometimes there, sometimes not. When it does, even if it's in small pieces or in big pieces here, it rises in the sky, it crosses it, and it sets again. The stars do the same thing at night. If you watch the constellation of Orion right now, early evening, you'll see it rising in the south, it rises in the southeast, it crosses to our south, and then it sets in the southwest. Everything goes around us. That's the original idea. And that stuck with us for a really, really long time. Except there were a couple of exceptions to that rule, and we'll take a look at those in a second. We now know them. We have 2 sets of planets in the solar system. We have what are called inferior planets and superior planets. Very simply put, inferior planets are those that are in an orbit closer to the sun. Superior planets are planets that are in a longer distance from the sun. Both of them have interesting characteristics. Inferior planets have phases, just like the moon. You put a telescope on Venus, it could be a full Venus, it could be a half Venus, it could be a crescent Venus, and the same thing happens with Mercury. It could be a full Mercury, it could be a half Mercury, it could be a crescent Mercury, it could be what's called a gibbous Mercury, or 3/4 full at any one time. But the planets that are behind us, we don't see them in phases. They do something else. And we'll give you that as a project to work on later on. They go through something known as retrograde motion. So assume that you're on the planet Earth right now, and let's say the planet Mars rises in the sky. And as it crosses the sky, if it were truly a case where the Earth were the center of the universe, Mars would just rise and then it would set across the sky without any motions here. However, this is actually what happens. Over a few weeks period of time, Mars will cross, its path will slow down, it will stop, and then it goes backwards a little bit, it stops, and then it goes forward again. Doesn't seem like a really big problem, but it drove people crazy. They couldn't figure out if the Earth is the center of the universe, or in this case, because we can see them with the naked eye, why do Mars, Jupiter, and Saturn undergo retrograde motion. And they wrote all kinds of mathematical formulas, and they wrote all kinds of ideas. And here was the big thing. If you want to truly be in power, you don't have to have the strongest army. You don't have to have the sharpest steel. You don't even have to have the most gold. We're learning this right now because we're in this new magical age. I was born in the end of the industrial age. We're now in a new age now here. The big thing to control is information. And we're learning that right now. We're learning those lessons in politics. We're learning those lessons in history. We're learning those lessons in science. We're learning those lessons in sociology. Information is the key to control. So organizations wanted to know this information, wanted to have this information, so then people came to them and said, what's happening with A, B, and C? They said, oh, I got an answer for that. Why is this happening? Well, I've got an answer for that. And if you had an answer for that, you controlled the information and you controlled the people. The church was big on this. Control the information and you can control the people. Nothing's bad or it's good. It's the way it was. So somebody come to a priest and say, Father, I've been watching Mars over the last couple of weeks and it's really weird. It doesn't cross the sky like the other objects in the sky, like the sun or the moon or Venus or Mercury. It does this really weird stop and go back and forth stuff. What's going on there? And they go through these explanations about what are called epicycles, elliptical motions, all kinds of different stuff that's going on. And we'll get into those in a few moments here. But before that, when Mars went into retrograde motion, people went to war. That was the other big thing. When the astrologers came up and said, you know, Mars is in retrograde motion, means Mars is kind of going, stop going, wait a minute. What are you guys doing down there? You're not satisfying my need for blood. Why? Because Mars is ready, it needs blood. Oh, we gotta go to war. And off they go. Or when the king says, you know, I got a problem, my neighbor across the way. I need their fields to feed my people, and we're gonna have to go take those. When's a good time to attack? And the astrologers say, well, Mars is in full motion right now. This is not a good time to do it. You might want to wait until Mars is in retrograde motion. That's when you do the attack. When Mars is ready to watch us, you know, give sacrifice to them. And that's how a lot of society worked. And that's how the kings made their decisions based upon motions of planets in the sky. Those planetes, the name the Greeks call for wanderers. So from early observations, inferior planets were never too far from the sun. Superior planets not tied to the sun exhibited retrograde motion. Superior planets brightest at opposition. Opposition means at opposite. So if that projector is the sun and I am the earth, all those people in the back of the room would glow the brightest. But if somebody was behind me, because the orbit's bigger, so it would be the sun, it would be me, and those planets, they don't glow as brightly. These are observations that were found. And inferior planets brightest near the inferior conjunction. In other words, as you're coming around the back of the sun, Mercury and Venus are at their brightest, they're coming back around to us. Here's an example of the early models of the solar system. They said that not only we'll use Jupiter here, not only did Jupiter go around the Earth, because of that epicycle, that back and forth they couldn't explain, he said there's got to be another orbit there. So it would do little loop-de-loops in its orbit, so it would look like it was doing this as it went around. And this loop-de-loop was the actual retrograde motion. And they made really, really complicated formulas. The smartest mathematical minds at the times were hired by royal courts to mathematically make this work. Why? Because we know the Earth is the center of the universe. So this went on for a long, long time. To give you an example of how long, it was well before the time of Aristotle, but Aristotle's credit because he wrote it down. He was credited with the idea of the geocentric model of the universe. A man named Claudius Ptolemy came along and mathematically backed him up. So this stayed for 1,500 years plus. So think about that a second. It's 2019, it's going to be 2020. Roll it back 1,500 years ago, and what was society like back then? What was society like in the year 500? So from then until now, that's what the belief was. That's how long the belief was. Now we've got this other idea that instead the sun is the center. They first started saying the sun is the center of the universe, but they didn't say the sun is the center of the universe. They said the sun is the center of the solar system. But they started figuring out, hey, wait a minute, if we do this, if I put the Earth in an orbit around the sun, put the sun in the middle, and if I put Mars in an orbit bigger than mine, and I watch its motion against the back of the stars, here's what happens. As you're coming around the racetrack, anybody here play track? Anybody here run track? Anybody watch track? Anybody heard of the word track? Hey, you heard of the word track, that's all right, we'll work with that. When they line them up, or even horse racing. Anybody heard of horse racing? Who's always the favorite when they line them up? Yes?
The first one?
The first one, the one on the inside track. Why? Because their path is the smallest. If you watch the Olympics, they got these people all lined up at an angle. You're like, why is the guy in the inside track all the way behind versus the guy all on the outside? Because when he yells go and they hit the starter gun, by the time they come around that first bend, everybody's even. And then it's a matter of seeing who's going to be the one who's the fastest. It's a way of making it fair. Why? Because as we go around the sun, our path is smaller. It takes less time to get around the sun than Mars. We see retrograde when we pass Mars going around the track. That explains it. But to get from this idea to this idea was contentious, it was ugly, it was bloody, it was terrifying to some people, and because of that, it took a really long time and some very, very brave scientists to push us past this idea onto this idea. See, we have this object over here. This is called a celestial sphere. And in our celestial sphere, let's turn the lights on for a second. In our celestial sphere, you see that the Earth's in the middle, the center of the universe. And this is how people used to view it. As the night went on, all of the stars that we saw rotated around the Earth. Even the sun, this little tiny yellow ball. Actually, let me get this is the right one here. Let me just turn this around. I'll put the United States so you guys can see the US. Yeah, the USA is on this side. The sun would rise, cross, and then set. So they even had a way of tracking this. This is kind of where the angle is supposed to be on. So it would be rise, cross, and set. This did not be one of the situations where we did this, where as it rotated, the sun actually stayed the Earth with it. No, they didn't think that way. That's the tail wagging the dog. It was everything moved and the Earth stayed in one spot. This is our example of a heliocentric universe. You can see on here, they broke these. All the little yellow dots on here represent stars. These are the major stars, the major patterns that we can map the sky out with. There's 88 of these. So if right now the sun is over here, I would say it's in the constellation of Aquarius. And if I move it over here, it's in the constellation of Libra. And actually the path that the sun takes as it goes around through the sky is called the zodiac. So that's where we get a lot of our terminology from, or a lot of our everyday beliefs and understandings and the basis for a lot of our beliefs and understandings come from this idea. Yes, ma'am?
Yeah, you stop.
Yes, you may. But then comes along Nicholas Copernicus. Nicholas Copernicus was a monk. He was actually a mathematical priest. At the time of Copernican time, if you wanted an education, if you wanted to be beyond a laborer in the field, whether you were a thatcher or a bricklayer or a baker or a stonemason or anything along those lines, if you weren't a serf that worked in the field, if you wanted some kind of academic job, you had to join the priesthood. Because they were the only ones that were doing reading, writing, and mathematics. Copernicus, believe it or not, was originally hired to prove the geocentric model of the universe, not disprove it. They hired and said, you know something? Claudius Ptolemy gave us some great ideas about the center of the Earth being the center of the universe, but some of his numbers are a little fuzzy. Could you do us a favor? Here's a little bit of money, here's a little time, here's a location. I want you to go ahead and clean up his math. We really want to lock this down because what's happening is society is getting smarter. Society is getting more educated. So what do they want to do? They still want to control the flow of information. So they want their answers to be, they want to dot their I's and they want to cross their T's. So they send out Copernicus to start looking at the heliocentric, the geocentric model. And he comes to a drastic conclusion, and it scares the bejesus out of him. Number one, he says, Earth isn't the center of the universe. I've run your models, and I tried to apply different ideas to it, and he actually winds up applying Occam's razor. Occam's razor was done by Sir Wilfred of Occam, who was a philosopher. And his statement is very simple. Given all the possible solutions to a problem, the answer is almost always exclusively the simplest one. So what's going to be easier? Having bunches of epicycles and changing information around and having to fudge mathematics and give this, well, there's things out there we don't quite understand. Or would it be easier to move this Earth out of the center of the universe, put it around the sun, just like one of these other wandering bodies we call planetes, and then rerun the numbers, and all of a sudden, boom, it all falls into place for him. He says Earth's not the center of everything. Center of the Earth is the center of the moon's orbit. All planets revolve around the sun. The stars are much farther away than the sun. This is an important one. This is what kept us in astrology for a long time. We thought that all the stars hung on a crystal sphere, and they were all the same distance away from us, not varying distances. So, that became a major shift. The Greeks actually thought of the idea that these planets and these stars and everything were really, really far away from us, but because they couldn't comprehend that the universe was really as big as it was, they just dismissed the idea. They said, nah, this can't be it. It's got to be Earth's the center of it. Because it's not the center of it, it's imaginably big, and we just can't wrap our brain around it. So that's that. The apparent movement of the stars around the Earth is due to the Earth rotating. The Earth's doing all of the moving, or 99% of the moving. Retrograde motion of planets is due to the Earth's motion around the sun. And this kicks us off into astronomy, because of the next guy here. His name is Galileo. We've all heard of Galileo. The telescope, now read this carefully here, folks. This is a common mistake, and I want to correct this for you. The telescope was invented around 1600. Galileo built his own and made observations. He did not invent a telescope. He is credited with taking the telescope and pointing it at the sky. The man who did it was a man named Hans Lippershey. He was a glass cutter. And he learned that not only you cut glass, but you can polish glass where it's thick at the center and thin on the edges, and it bends light and magnifies. And when you combine these things together, big lenses and small lenses, did a lot of tinkering around, he found that he could see things really, really far away up very close. And he'd get himself a big piece of leather, and he'd roll 2 lenses at each end in this leather till it made a tube, like a cigar. The military picked up on it instantly. They said, this is something significant. Why? Because instead of standing at a castle wall on the coast and looking out, seeing if ships are coming to attack your city, you could put one of these. He called it an object that sees very far up very close. That's what he called it. Real creative name for an idea. But he realized that, hey, if we put one of these on the walls, we can see the enemy coming a lot quicker than others, so we can prepare for it, get our defenses up, get our supplies ready, get our troops in order here. This is valuable. So it was around for a few years. I think it was around 8 or 9 years before Galileo goes to a market and sees this thing, and he goes, I can make one of these things. And he made it for himself, because Galileo was, amongst many things, Galileo was a tightwad. Galileo was legendarily cheap. He had lots of problems with money his entire life, which we'll talk about if we get to Galileo, we'll talk about another time. But instantly he says, you know something? Instead of doing this, what happens if I do this? And he looks up at the sky, and he learns a lot of different things that tie into Copernicus and his ideas about the Earth not being the center of the universe, but the sun is the center of the universe. So what does he find out? He finds out that the moon has mountains and valleys. He finds that the sun has sunspots on it, and the sun also rotates. He found moons, Jupiter has moons, and he finds that Venus has phases. The suns and the sunspots are eventually what cause him to go blind. When we look up at the sun, we always see the glare, we look away from it, it protects our eyes. It's a natural reflex. Galileo took beeswax and he dripped it on the front of the lens of his telescope so that he could look up at the sun and there wasn't any glare that he could keep staring at. The problem was, while it blocked out the bright visible light, it didn't stop the ultraviolet rays coming in and frying his cornea. And after many years of him doing observations, it basically burned out his eyes, and by the time he was in his 70s and ready, he was arrested for all things he'd done, he was practically blind. So he was kind of the test sample. As you see over here, you see it says 7, 8, 10, 11, 12, 13, 15. These were days of the month where he put his telescope onto Jupiter. Jupiter is these large circles. If you notice, each day there are dots. He has the 7th, 8th, the 9th he couldn't see because it was cloudy. The 10th, 11th, 12th, 13th, to 14th he couldn't see because it was cloudy. But if you notice that these stars that went around, or right next to Jupiter, right next to Jupiter, kept moving, and he came to the conclusion that these were stars that went around Jupiter. So, what's the big deal? Mountains and valleys, sunspots, Jupiter, Venus has phases. So what? What's the big deal here? At the time, the belief was this. When you asked about the universe, any informational institution that had power, see the church, they said that the heavens are perfect, unchanging, celestial, heavenly bodies. It's like you saying the Big Bang is the creation of the universe. That's how ingrained it was into their minds. Perfect, unchanging, heavenly, celestial bodies. Okay, so then, first question. If they're perfect and unchanging, why does the moon have mountains and valleys on it? How do you know that? Because the mountains cast shadows, and the craters cast shadows, and you can see them with this telescope. Well, it means it's not a perfectly flat surface. It's got bumps and ridges and cracks, and that's not perfect. He found the sun had sunspots. Wow, that sun's a pretty significant thing in almost every religion and almost every idea that we talk about in nature and the system. Almost all energy in the universe for us starts from the sun. it's got sunspots. And it moves. Well, wait a minute, it's got sunspots, it's not perfect. And it's unchanging. Well, it is changing, it's rotating all the time. Jupiter has these moons. If we're the center of the universe, then why in the world are all of these moons going around Jupiter? Not cool. And then Venus, we told you had phases. At a full moon, at a full Venus, half of Venus, a gibbous Venus, or three-quarters Venus, a crescent Venus. So we were seeing changes in motion, so it threw things into question. For example, here's the Earth, here's the Sun. If I put a telescope on Venus here, this is what it looks like. I put a telescope on Venus, here's what it looks like. If I come over here, if you put the Earth in the center of the universe, and the Sun orbiting and Venus orbiting in its own little wacky circle here, you don't get phases either. So it kind of starts throwing questions at things. Then comes a man named Johannes Kepler. Kepler is probably going to be considered the single greatest scientist of all times. Take any one person, take their life's work and boil it down and come to conclusions. Kepler was number one. It's not scientists today. It's not Hawking. It's not any of the people you think of here. It's not Einstein. It's not even Newton. It's not Aristotle. It's Kepler. And the reason why was very, very simple. To put it in a nutshell, because I don't want to drag too long in this class, I have a video I'll show about the life of Kepler later. He had a lifelong idea how the universe was put together. And when he went to Tycho Brahe, was the guy, the picture you see here, and he eventually, it was a long dragged out story, he eventually got the data from Tycho Brahe, he found that all of his ideas were wrong. He was 0% correct. He blew the entire thing out. Up to this point, most scientists would fudge the data.